Hey everybody, in this lesson we're going to talk about finding molar mass. So molar mass relates to atomic mass and can be used as a conversion factor. So, what is molar mass? Well, it's the mass in grams of 1 mole of a particle. And this particle could be, for example, an element, it could be a molecule. This unit of it thus is grams per mole because it's how many grams you have per 1 mole of that substance. So example, carbon. If we look at the periodic table of carbon, we see that carbon is 12 grams per mole. So if you had 1 mole of carbon, it'll be 12.0 grams per mole. If you look at, for example, iron is, if you look over here, iron is 55.8 grams per mole. So if you had 1 mole of iron, it'll be 55.8 grams per mole. Why am I showing these? Because these fractions, guess what, are two different units. They are conversion factors now. So what else do we need to know to find the molar mass? Well, if we deal with a molecule, because each molecule has a different number of elements, then that means that we're going to have to find how to find its molar mass. So chemical formulas tells us what elements are present and how many we have. So for example, if we look at, for example, Na2SO4, what this tells us, we have 2 sodiums, we have 1 sulfur, and we have 4 oxygens. Okay, so that's what it tells us right there. Now, if we know the mass of 1 sodium, we can easily find the mass of 2 sodiums. If we're trying to find the mass of 1 oxygen, we know the mass of 4 oxygens. So how do we find the molar mass of any compound then? Well, our first step is find the chemical formula. Okay. And then what you want to do, number 2, is multiply number of each element by its molar mass. Step 3, add up all the masses from step 2. Okay, let's practice this out. So let's look at CH3COOH, which is acetic acid or vinegar. In this example right here, we have, as we can see, we have 2 carbons. So if I write this out, we have these elements. We have carbon, we have hydrogen, and we have oxygen. Okay, we have 2 carbons, which I'll highlight in yellow. We have 4 hydrogens, and we have 2 oxygens. So in total, we have 2 carbons, we have 4 hydrogens, and we have 2 oxygens. Okay, what is the mass of 1 carbon? Well, based on the periodic table here, the mass of 1 carbon, or 1 mole of carbon, is going to be 12. So that means here we multiply this by 12 because we have 2 carbons, or 2 moles of carbon. Okay. Alright, what about hydrogen? Hydrogen is right up here. We see that hydrogen, 1 hydrogen is 1.0, then we multiply it by 4. Okay, oxygen. Oxygen, is 16. 1 mole of oxygen, or 1 molecule of oxygen, is 16. Okay. What we have here, thus, is we have times by 2, so 16.0 times by 2. Okay, so if we add all up, this is 24, this is 4, and this is 32. If we add this all up, the molar mass of CH3COO is going to come across as 60 grams per mole. So if we had 1 mole of acetic acid, it will have a mass of 60 grams. Okay, let's take a look at our next example. We have C, carbon, We also have hydrogen, and we also have oxygen. So same type of chemical elements used, but the different ratios of them. So how would the mass change this time? Well, we have 6 carbons, we have 12 hydrogens, and we have 6 oxygens. We know the molar mass of carbon was initially was 12.0. That doesn't change. So our total mass of 6 carbons is 72.0. We have 12 hydrogens, each one is 1 grams per mole. Our total mass here is going to be 12.0 grams per mole. Oxygen is 16 grams per mole, there's 1 of them, but if you have 6 of them, it'll be 96 grams per mole. So now we add all these. If I put just on my calculator and I add them all up, I will get the value of 180.0 grams per mole. So if I have 1 mole of this chemical, I'll have 180 grams of it. Alright, let's practice with the next 3 examples. So the next 3 examples here is, as we see, we have our chemicals nitrogen, hydrogen, phosphorus, and oxygen. Okay, so let's label how many of each we have. In this chemical right here, how many nitrogens do we have? Well, NH4 only has 1 nitrogen, but because we have 3 NH4s here, we actually have 3 nitrogen atoms. Hydrogen, we have 4 hydrogens per each ammonium, but there's 3 ammoniums, so we have 12 hydrogens. We have 1 phosphorus and 4 oxygens. Okay, now 1 nitrogen is 14. So the molar mass of nitrogen is 14, but we have 3 of them, so we multiply by 14 to get 42.0. Hydrogen, we did this before, is 1 gram per mole for 1 hydrogen, but we have 12 of them, so in total our mass there is 12.0. Phosphorus. Phosphorus is right here. Phosphorus molar mass is 31. So it becomes 1 times 31.0 is still 31.0. And last but not least, oxygen is 16.0. 4 of them will give you 64.0. So now, if we add these up, 42 plus 12 plus 31 plus 64, and we get a molar mass of, as we see here, 149.0 grams per mole. Alright, so let's work on our last 2 questions here. So our chemicals in this one are copper, sulfur, and oxygen. The mass of 1, so we have 1 copper, we have 1 sulfur, and 4 oxygens. The mass of 1 copper, right here, is 63.5. So we multiply this by 63.5. The mass of 1 sulfur is 32.1. So we multiply by 32.1. And oxygen again is still 16.0. So 1 times 63.5 is still 63.5. 1 times 32.1 is still 32.1. But 4 times 16 is 64.0. So now we add these all up. And when we add all these up, we'll get the molar mass of CuSO4, which ends up being 159.6. 159.6 grams per mole. Our last one here is iron 3 nitrate. So in this case here, we have iron, we have nitrogen, and we have oxygen. We have 1 iron, we have 3 nitrogens because there's 3 of these polyatomic ions, and we have 9 oxygens. Okay, the mass of 1 iron is 55.8. So we multiply this by 55.8, and we get still 55.8. Nitrogen is 14. 1 of them is 14. So 3 of them is 42. Oxygen. 1 oxygen is 16.0. What's 9 of them going to be? 9 times 16 is 144. So our last step now is to add them all. And if I add them all, what do I get? 55.8 plus 42 plus 144 gives me 241.8 grams per mole. So this is how you find molar mass of compounds. As always, make sure you keep yourself safe and healthy, and I'll see you soon.